Tesla has already decided that Optimus is worth more than its car business, and it proved that on May 9, 2026, when the final Model S and Model X rolled off the Fremont line and the factory floor was immediately converted into the first Optimus production line. That is not a startup pivoting. That is the world's most valuable car company making an irreversible manufacturing bet on humanoid robots, one backed by more than $20 billion in 2026 capital expenditure, 15 million square feet of new factory space, and its own dedicated AI chip. This video breaks down exactly why that bet is more defensible than most people realize. And it starts with a patent that most observers overlooked. The knee joint patent Tesla filed reveals something more important than a clever mechanical design. It reveals a manufacturing philosophy. Traditional humanoid robots use multiple rotary motors clustered around the knee, sometimes 2, 3, or 4 actuators working in combination to generate sufficient torque and range of motion. That approach works in a lab. It fails at scale. Multiple actuators mean higher weight, larger batteries, more complex wiring, greater heat generation, and significantly higher production cost per unit. Tesla's engineers studied the human knee anatomically, the femur, tibia, patella, quadriceps tendon, and patellar ligament, and asked what the minimum mechanical system would be to replicate what that biological architecture actually does. The answer is a single compact linear actuator combined with a 4-bar linkage mechanism. The actuator inside the thigh moves through only roughly 60 degrees of travel. The 4-bar linkage then mechanically amplifies that smaller motion into approximately 150 degrees of lower leg rotation, closely matching the natural human knee range of 140 to 160 degrees. In effect, it is a leverage system that mirrors how tendons and the kneecap amplify muscular force in the human body, allowing a smaller actuator to produce a larger and more efficient output. The result is a robot that can crouch, squat, walk, and climb stairs with movement patterns that look significantly more natural than any competing design. And it does all of that with one actuator instead of 3. That 1 versus 3 actuator difference matters far more than the mechanical elegance alone suggests. Elon Musk has stated repeatedly that Optimus must eventually reach a production cost of $20,000 to $30,000 per unit to achieve mass adoption. Most existing humanoid robots today cost between $100,000 and $300,000 and are produced more like research prototypes than consumer products. The gap between those two price points is not primarily a software problem, it is a hardware and manufacturing problem. Every component reduction in a humanoid robot has a cascading effect throughout the entire system. A simpler knee requires fewer actuators, which reduces weight. Lower weight reduces torque requirements across every other joint. Lower torque requirements mean smaller motors throughout the frame. Smaller motors mean smaller batteries. Smaller batteries reduce total weight further, lowering torque requirements again. The efficiency gain compounds in both directions simultaneously. When that cascade is applied to both legs of every robot across annual production volumes in the millions, the economic impact becomes the difference between a $25,000 product and a $150,000 one. This is why Tesla's approach is not just mechanically interesting. It is the economic foundation of the entire mass-market robotics thesis. And it is built into the hardware before a single line of AI software is written. The competitive response already validates how seriously the industry takes Tesla's direction. XPeng's Iron Humanoid robot, introduced in late 2025, was immediately flagged by analysts for incorporating a modified linkage system and hip configurations that closely resembled Tesla's patent filings. Tesla had publicly demonstrated these concepts years earlier at AI Day and documented them exhaustively in international patent applications. This is the pattern Musk explicitly described when explaining why Tesla has not fully unveiled Optimus 5.3. By the time a competitor analyzes and copies one generation of hardware, Tesla has already moved to the next. Xiaomi's Cyber One, widely compared to Optimus Gen 2 when it launched, arrived after Tesla had already demonstrated that version in December 2023 and had moved internal development to Gen 3. The Optimus 5.3 reveal is now expected in late July or August 2026, deliberately timed close to the start of mass production to limit the window competitors have to study it before it ships. The competitive dynamic in humanoid robotics is not a race between equals running at similar speeds. It is a race where the leader is setting the pace and designing the track. The manufacturing infrastructure being built to support this advantage is unlike anything in the robotics industry by an enormous margin. At Fremont, the Model S and Model X production area has been fully restructured into a first-generation Optimus line targeting up to 1 million units per year. At Giga Texas, Tesla has filed permits for more than 5.2 million square feet of new factory space at the North Campus, bringing the total Giga Texas supercomplex to a projected 15 million square feet by end of 2026. A scale explicitly designed for a long-term target of 10 million Optimus units annually. The 2026 capital expenditure plan confirms more than $20 billion committed to 6 new robotics and battery production lines and the Cortex 1 and 2 supercomputer systems in Texas, equivalent in compute to more than 230,000 NVIDIA H100 GPUs dedicated to Optimus AI training. The AI5 chip, the dedicated reasoning processor for Optimus, completed its design in April 2026, ahead of schedule. For context, most competing humanoid robot companies produce dozens to a few hundred units per year. Tesla is building infrastructure for tens of millions. Musk acknowledged in the Q1 2026 earnings call that the 2025 internal deployment target of 10,000 Optimus units inside Tesla factories was missed, and that no robots are yet performing useful work at scale in Tesla's operations. The commercial timeline has shifted. The Fremont test version is now targeted for end of summer 2026. First business-to-business customers by end of 2026, and the mass-market consumer version at the $20,000 to $30,000 price point pushed to end of 2027. Those delays are real and worth acknowledging, but they are delays in a program that is simultaneously building 15 million square feet of dedicated factory space, finalizing its own AI processor, and holding joint architecture patents that competitors are already copying frame by frame. Forearm thickness has been increased to accommodate 25 advanced actuators. Automated assembly processes are being progressively refined so that machines build machines. The question the robotics industry faces is not whether Tesla's timeline will slip again. Given the complexity involved, it almost certainly will. The question is whether any other company will be operating at remotely comparable manufacturing scale when the technology matures. And based on what satellite imagery shows being built in Austin right now, the answer is no. If you want this depth of analysis on every Optimus development as it happens before the mainstream catches up, subscribe. That is what this channel delivers.